To me, what makes physics physics is that experiment is intimately connected to theory. It's one whole. I, ADARSH CHETTRI, student of Namsi Government College, bearing roll number 20NS0400, would like to welcome you on this experiment on determination of end correction of meter bridge and to measure the specific resistance of a material in the form of a wire. Under the guidance of Dr. C.P. Khatewada, Faculty, Department of Physics. Apparatus required: 1. Meter bridge. 2. Resistance. 3. Resistance box. 4. One-way key. 5. Jockey. 6. Galvanometer. 7. Source of EMF. 8. Screw gauge. 9. Connecting wire. Now let us know what is a meter bridge. A meter bridge is an electrical apparatus using which we can measure the value of a unknown resistance. It is made using a meter long wire of uniform cross section. This wire is either nichrome or manganese or constant because they offer high resistance and low temperature coefficient of resistance. A meter bridge or slide wire bridge is designed from a Wheatstone bridge. It is the most basic and functional application of a Wheatstone bridge. Let us have a look at the diagram of meter bridge. Now, what is end error and how to overcome it? End error means the shifting of zero of the scale at different points as well as the stray resistance due to non-uniformity of metal wire gives rise to the end error in meter bridge. End error can be removed by repeating the experiment by interchanging unknown and known resistance and finally taking the mean value of resistance obtained in each experiment. Formula to overcome end correction. R by S equals to L plus L1 divided by 100 minus L plus L2, where L is the length of meter bridge wire and L1 and L2 are the additional length included at the ends. This is the image of a galvanometer through which we can come to know the end error if the deflection is not at zero. That is, it keeps on changing. Let us know the principle of meter bridge. The principle of working of a meter bridge is same as the principle of a Wheatstone bridge. A Wheatstone bridge is based on the principle of null deflection, that is, when the ratio of resistance in the two arms is equal, no current will flow through the middle arm of the circuit. Let us consider the diagram of the Wheatstone bridge as shown aside. It consists of four resistors P, Q, R, and S with a battery EMF E. In the balance current, no current flows through the galvanometer, and the terminals B and D are at the same potential. This condition arises when P by Q equals to R by S. To measure the resistance of the wire, place the jockey in the meter bridge and check the deflection in the galvanometer. If the deflection is shown in either side by taking the jockey in the meter bridge, then the connection are right. Now take out a known resistance from the resistance box and switch on the battery alimenter and insert the plug key. Check for the zero deflection by moving the jockey. Note down the values in the observation table. Similarly, take out the next known resistance and carry out the same process. These are the arrangements done in the meter bridge. The device in the end is known as jockey, which is used to move on the meter bridge wire as shown. This is a galvanometer. This is a resistance box, non-resistance box. This is a battery MF. This is a plug key. We can find the unknown resistance using known resistance, where known resistance is the resistance box. So this is the arrangement of the meter bridge. Let us take an example to calculate the resistance of a wire. Let us consider two resistance, known resistance 7 and 10, whose null deflection were shown at length of the wire of meter bridge at 60.1 and 68.1 respectively. So 100 minus L, where 100 is the total length of meter bridge. So 100 minus L in the first case becomes 39.9 and in the second case becomes 31.9. So the mean resistance of each, both the resistance, non-resistance value is coming as 4.6 and 4.6. So after calculating the mean value, X becomes 4.6 ohm. To measure the specific resistance of a material in the form of a wire, first calculate the mean resistance using meter bridge. We need to find the diameter of the wire using screw gauge. There should not be zero error. Note the least count of the screw gauge. Place the wire in between the stud and screw of the screw gauge. Note down the main scale reading and circular scale reading. Here in the diagram it is shown measuring the diameter of the wire using screw gauge. We place the wire in between both the screw where A and B and note down the value from this meter scale. Let us take an example and have a calculated diameter be 0.42 into 10 to the power minus 3 meter. So this is an example of specific resistance calculation, where previously we had calculated mean value is equals to 4.6 ohm, diameter calculated using screw gauge equals to 0.42 into 10 to the power minus 3 meter. For finding out the specific resistance, the formula is XA by L equals to X pi d square divided by 4L, where area is equals to pi d square by 4 and d is the diameter of the wire found out using the screw gauge. So this is the calculation: 4.6 into 3.14 into 0.42 into 10 to the minus 3 into square divided by 4. So the final value we get as 0.6 into 10 to the minus 6 ohm meter. So thank you for watching this video. If you like this video, please like, share and subscribe the channel.